Welcome back to One Day Online Summit on Electrifying India, Innovation, Infrastructure, and Intelligent Mobility for Sustainable Future. Organized by Department of JSS University, Noida. Post lunch, now we have a case study session by Dr. Ramesh Singh from Tata Elxsi, New Delhi. Dr. Ramesh Singh Dr. Ramesh Singh is an accomplished professional with about 25 years of experience in electrical engineering and product management. He holds a Bachelor of Engineering degree from REC Hamirpur and MTech from NIT Jamshedpur. He earned his PhD from Delhi Technical University. Dr. Ramesh has made substantial scholarly contributions with papers published in reputed international journals and presented at prestigious international conferences. His research spans cutting edge areas in electric vehicle technologies, microgrids, and sustainable energy solutions. Currently, Dr. Ramesh serves as a senior principal manager at Tata Elxsi, where he leads key projects within the energy domain. He plays an instrumental role in driving innovation in microgrids, renewable energy, smart grids, energy storage, electric vehicles, and sustainability projects, collaborating with various national and international organizations. In addition to his corporate role, Dr. Ramesh is an active senior member of IEEE USA, Ambassador IEEE Smart Cities USA, and EXCOM member IEEE CAS Bangalore. Today, Dr. Singh will be presenting a case study on EV industry success stories in India. Welcome you, sir, and over to you, sir.
Thank you, Abhilasha. It's a pleasure to present my thoughts over here to a wide audience. I hope 50 plus nearby participants are there. And I'll switch off my camera after some time because of the bandwidth limitations. I hope that will be fine with all of you, right?
Yes, that's okay.
So, small correction that I'll be having, and I'll request you people to adjust. I will be giving a case study of energy, which EV is also a domain of. I'll be giving a case study of India, how India is moving as the energy is progressing, right?
Fine,
So,
sir.
going with the theme electrification and the various pros and cons and the in-depths of energy in the terms of generation, transmission, distribution, and utilization. EV covering some of the portions is obviously a part of these. So, I hope that is fine. I'll start my presentation.
Sure. Sir.
And excuses if I cough a lot of times because I had been in a bad viral fever from past few days. Sorry for that.
That's fine, sir. We are very thankful you have accepted our invitation and been here.
It's a pleasure. I hope is my screen
Yes,
visible?
sir. Yes. Yes, sir. We can see your screen.
Now in a presentable mood also, I suppose.
Yes, sir.
So going with the topic, electrifying India, innovation infrastructure, intelligent mobility for a sustainable future. I'm very much glad that JSS has come up with such kind of theme because India is nowadays on a very strategical position where it has to decide upon its generation, transmission, distribution, and utilization kind of features. Because conventionally, what India was being supported by the coal industries, by the coal generation, and the bigger kind of factories and setups, the power flow was uniform from one level. And coming to the utility or the home section or factories, the voltage level was gradually depreciating or it was decreasing. So, as the demand grew, the incapability of conventional power sources came in picture, and hence came forth the utilization or the development of renewable energy sources with the distributed energy resources kind of platform. So my talk is somewhere the case study for India, where we have different kind of sources, different kind of loads, and the control algorithms, and how we are coping up and what needs to be done in the recent future day from now onwards. So electrifying grid overview, if we say of right, the agenda of today's talk will concentrating wow and how AI and digital twins are playing their roles. AI has been in picture and in wind talks since long, but nowadays because of different kind of LLMs and companies, ventures, startups, it has grown a lot of attraction. And digital twins are a new kind of platform which are being utilized. Earlier, digital twin was only for the aerospace kind of thing for the uh, aviation industry, you can say, but now it has come down to every motor, batteries, and transmission and distribution substations also. How they are being used in the optimization and effective control of energy systems. Second topic that we will be covering today will be how the scalable charging infrastructure around India is playing its role and what should be the support which we as a common individual, state governments, utilities, and the distribution companies, discoms, and the center as a whole has to play. Very important part of all these segments is the power electronics part, where the different advancement in the power electronic controls, topologies, switching factors, and the algorithms are playing their role for the effective control and the utilization of grid energy and EV as a segment. Lastly, the very new kind of offshoot, which is a smart grid integration, cyber security along with that, how these are being orchestrated as the EVs are interacting with the smart grid and different IR and DERs are also in cooperation with the discoms are playing their role. Cyber security plays a very important feature and how demand response curves are being affected or should be tweaked upon to cater these kind of segments. So the Indian electrification landscape, if we see the electrical mobility growth, it has been growing. Different kind of state and government subsidies, FAME policies are being supported. Different states have also given some kind of incentives for the EV buyers and also for the companies which are working in these segments, let it be for the powertrain, for the battery assembly, or the EV production as a whole. The renewable energy deployment is there because solar is now increasing a lot. Earlier, in an era of 2000, we had a lot amount of wind sources spread across India in the coastal regions, in the east and west both. Suzlon was one of a major company which was leading this one. But now, as compared to the rate of growth and the percentage of energy production, wind has been surpassed by the solar PV kind of systems, and how this dynamic load management is being taken care of because either it be wind or solar, both are intermittent. And this intermittency is a very kind of big issue, which we will see in our coming upcoming slides, how they are playing their role and what should be done to cater the negatives that are being done harm to the end users. Finally, the digitalization transformation, the everything which was earlier when we used to study was analog circuits and analog, the continuous current waveforms, voltage waveforms, frequency. Everything has now been discretized and digital features have been incorporated along with the operational efficiency, which is now being supported by AI because the data that we are all having in the form of digital formats and digital twins again play a very important and crucial role for the management of all of these. A small pictorial data representation, I will say, which I have taken from some government sources, which say that the total energy generation, how it has increased from 2018 to 26, which is still 26 is coming to be. So it is a projected kind of thing. We see that there has been a significant amount of growth in the total power generation. The peak demand, as we can see, is has almost increased near about double, you can say, from 170 to 270. The EV load demand with a inclusive increase of load to 5 to 7% year on year is going to be a next crucial kind of load. And another kind of load which I am not mentioning here is the data centers. The data centers load is exponentially rising. It is not rising in the terms of some percentage, 5 or 7. The data centers load is exponentially rising, and it is the latest kind of load segment, I would say, in the whole electrification landscape, not only for the India, across the globe. And because of that, only all of us know that what Elon Musk is doing in that field. To curtail all these, we have some solar or wind kind of generation systems where solar has obviously increased 5 times, more than 5 times across all the segments in India, whereas wind has also increased near about twice the whole segment. Due to intermittency, the best capacity is also increasing. It has increased a manifold, but still it needs to be in a much rigid shape, which we will come to know why it has to be there. This is a small pictorial representation of the whole Indian scenario where I have considered from 2018 to 26 only. If we go back, then these curves will be much more uh, elongated and they will show a different profile. I am showing some recent past only, where what I have told, the generation has increased 44%, solar share is increasing 7 to 8% annually. The renewable energy is now some percentage of the whole one. Best capacity has increased. Peak load demand has increased a lot of times, and the EV load demand. I'm not considering here again, I'm mentioning data centers because in some months the data center will be a heavy kind of segment apart from EVs, which need to be taken care of. The main problem with the data center is the randomization of the load segment or the pattern. We cannot predict at what time the load will be what, and not only that, the carbon neutral kind of you can say mandate has come across globe according to the Paris Agreement, and also in India, mid 2025, the government of India has mandated carbon neutral data centers. So by the end of 2026, the apart from EVs, we will have one more segment which is totally unpredictable. We can predict somehow wind, we can somehow predict solar, but data centers is totally unpredictable one till date. And now we will come to the AI technologies, how AI is reshaping and helping India in build all these kind of electrification demands. So the demand forecasting is being supported with the help of AI. AI, as we know, is a data hungry kind of system. Conventional AI is a data hungry kind of system where the different load patterns are being given to some kind of LSTM, RSTM, or different kind of models of AI. And the different ML algorithms work upon that, and henceforth they predict what kind of season, what kind of month or day or timing the energy demand will be. And because of that, each utility or the DISCOM is able to buy or purchase that from the PGCIL. So this helps in regulation of the frequency and the voltage form because P and Q both are being effectively controlled. So V and F are also being taken care of. AI is also being used in the EV charging and the network optimization part because now the conventional EV chargers were only having, depending upon the SOC, there was no other factor which was being taken care of. If the SOC is less, they will draw constant C, constant V, CV, CVCC kind of charging infrastructures were there. But now it is something like that. It is also going to depend upon the discom utility rates of the power. If the power is cheaper in the night, the EVs will be charging in the night. And moreover, apart from that, if we will see that voltage profile or the frequency profile in the night time because of the flat rates or less rates everyone is putting at that time. The frequency is falling. So EV will stop charging. Extra uh, pollution of that will be if I will be charging that EV in my office at that time or some other time in the evening or some afternoon features when the solar irradiance and the penetration is more. So those kind of intelligent systems are coming there, and we do not, I or anyone, let it be Rahat is there also on the call. He also, if he is having an EV, they won't be bothering about what kind of features the utility is going to provide me. It will be depending upon the SOC and SOH, and accordingly, it will give a charging pattern. Not only for the charging, it will also give a discharging pattern. Let it be, it will help us in the demand response curves. If the evening frequency profiles are falling, my SOC is 90 to 95%. I can go at a local, you can say, hub charger hub spot, and I can discharge my SOC up to 80 because I need only 5% of SOC for reaching my home. So this is how AI is playing the role. Major AI role is again playing their role in the predictive condition monitoring, where different kind of anomalies are being there, both in the terms of batteries, motors, EV as a whole, or smart grids, any utility, let it be my refrigerator, AC, washing machine, hair dryer, a ceiling fan, anything. So different kind of anomalies usually creep up when different kind of harmonics and disturbances are there in the either stator, rotor, or the bearing part. So there is a different fault tree, and depending upon the different fault trees, the predictive maintenance takes their role. It catches what can be done in the near future to save the downtime and aid to the sustainability part of the whole ecosystem. So next is the system optimization and the sustainability part, because sustainability, the word has come to us in the recent past, but we being an Indian people, we know what sustainability means from daily our childhood, starting from the clothes, brushes, toothbrush, shoelaces, and the ironing and the different food items that we had in our home. Everything was a part of sustainability, but covered in a different wireframe. But now the coin of sustainability word is there. Excuses for my coughing. And by integrating AI, we are in a well solid position to aid the sustainability part and the, you can say, Paris Agreement treaties and issues for the asset managements. Now, coming what the digital twin is. I'll just ask Abhilasha or the presenter and any organizer, are the audience also unmute or I am only unmute? Sanjeev sir, Udit, Abhishek, anyone? Rahat? I'll request the organizers to unmute everyone so that I can have a brief kind of discussion with them. Will that be fine? Sanjeev sir, am I audible? Okay, I'll go. I'll keep on like this only. So the thing is digital twins, right? So it is something in the terms of EV, if I say there is a cell called, we give names to every cell, right? Because it's a nomenclature, everyone has to be given. I say that let it be a bat 101 is the name given to a cell, which was manufactured by a company, I won't take any name, XYZ. And the chemicals are coming from Africa, some portions, and the different.
Hello, just I'm disturbing, but I am now. I am. receiving your sound, sir.
बीच में गायब हो गया था क्या सर?
हाँ, थोड़ी सी टेक्निकल इशू ऐसे था।
मैं ये रिक्वेस्ट करूंगा कि ऑडियंस को, अब आप सारों को अनम्यूट कर दो, मैं बात करना चाहूंगा।
जी सर।
बात करने से थोड़ा ज्यादा बात क्लियर होती है।
जी जी।
थैंक यू सर।
म्यूट करना, अनम्यूट कहाँ से होगा ये खुद क्यों नहीं
सेटिंग्स में जाके अनम्यूट ऑल हो जाएगा।
कर।
So let it be a battery bat, the name that I give 101 is having some chemistry, it has some capacity, but the story of bat 101 didn't start the day it was born. Bat 101 story much started much earlier than it was physically that than it physically came in picture in this world.
Excuse me, sir. Would you like to unmute them or allow them to check?
Unmute,
Unmute.
unmute कर दीजिए
Okay,
सर।
sir. Fine.
Thank you sir।
Now all are unmuted, sir. Please.
राहत खान unmute हो।
Unmute themselves, sir. No, अपने आप को नहीं कर सकते। Now from my side, they are free to unmute themselves.
ठीक है सर।
Thank you.
Thank you sir। Am I audible to rest of the audience? If anyone can just say me hi.
Yeah, hi.
Yes, sir.
Audible, sir. Audible.
Hi, sir.
Thank you very much. So the thing is, I'd like to this session to be interactive क्योंकि सुना बोला बहुत कुछ भाई। जब तक इंटरेक्ट नहीं करोगे ना मजा नहीं आता। That's my whole funda is for this talk. I hope the organizers को बुरा नहीं लगेगा मेरी इस बात से।
It's
Digital
completely, it's completely fine, sir.
digital twin I'm talking of. So the battery's life cycle didn't start from the day it was born. It started much months ahead. And not only one feature of that was born, many alterations, simulations, and algorithms were made for that cell BAT101. How its capacity will be, what will be its SOC and SOH, what will be its first life cycle, what it will do in the secondary and tertiary, and what will be the chemical compositions, what will be the welding features, and all those. So, this is what the digital twin is. Before anything is made, it is not necessary always before anything which is far away from the physical world. If some simulation or emulation is being done, then it forms a form of a digital twin. And the help of that digital twin is not only something else, but only to facilitate a real-time monitoring in the simulation part. So let it be BAT 101 was born on let it be day today, 29th June 2026. But the simulation started let it be 8th Feb 2026. And in this whole 5 months, it has gone through a rigorous process of SOC, SOH, RUL calculations, cell chemistry, what will be the shape and size and everything. Now it is coming in a picture. It has been placed in an Ola EV, Ola two-wheeler. Now Ola two-wheeler is bought in Bombay and now it is going to Jaipur. Now the SOC, SOH are being defined from a particular kind of constant and they are fixed from all over India. But the Jaipur conditions are somewhat different. Now the BMS will be giving a separate protocol because BMS is supposed to be the brain of that battery system. BMS is telling me कि bat 101 now you cannot discharge this much amount of current at this C. You should decrease your C. Although the C was defined to be discharged, the battery was defined to be discharged at 1.5 C. It is now discharging at zero point 0.8 C. This is what the digital twin acts for, and this is how it is acting. So for all physical assets, grid or EV assets and renewable energy plants, this is helping a lot. In the EV infrastructure, the charging model that I told in the previous slide, it will also see if my battery is being charged at the night, but because the utility rates were very less, but now my BMS is sensing a rise in temperature above some limit, so it will stop charging. And this is how digital twin is again coming in picture. Digital twins again help to reduce downtime because something anomaly is going to happen. They stop it month in advance, and predictive maintenance, or better to say, predictive condition monitoring, is taking place. Applications across the energy ecosystem, because it starts from the generation to the transmission to the distribution to the utilization part. And utilization, a small segment of that is the EV, and the upcoming one, very important, is the data center one. So digital twins now incorporate everyone, and we are working with all these kind of digital twins. Let it be for the generation plants of EV, PV, and wind for national, Indian and international companies in US, UK, and Australia. We have been incorporated with the transmission systems, transcoms, and discoms in India and abroad also. Now, what we are seeing from a company point of view, I'll say digital twins are now a very small all segment which are now changing or disrupting the whole energy ecosystem. So now AI is coming in picture with the help of digital twin, and the real time anomaly detection is being taken care of, which is avoiding any kind of failures, because any kind of anomalies, they can creep up any kind of fault. They are stopping in advance. Predictive maintenance and optimization of assets, not only assets, the energy systems also. How much efficient, how much efficiency, how much will be the power factor, how much will be the total harmonic distortion of that system. This AI is going to predict with the help of digital twins. The scenario and the grid simulation planning. How much should be my PV panels? What should be the size of my wind farms? What should be the nickel motor size? And what should be the strategic decision? How should be I orchestrating the different kind of wind, PV, and BESS kind of systems? So AI is playing that role over in there. And enhanced grid resilience, because digital twins are also a part of microgrids. So the grid resilience, or that is there, which can support a different kind of sustainability in the whole ecosystem. Because if any kind of fault or anomaly is there, let it be Noida, if you people are in Noida and some fault is there in let it be Dadri substation, right? So some substations of Greater Noida will be cut off, and they will be feeding some of the local loads in an islanding mode. So this is what the amalgamation of AI and digital twin is taking place of care of. Now next is the charging infrastructure and the business models associated with that. Now everything which we are talking of, finally EV needs to be have some charging infrastructure, because we have this chargeable EV systems, and the infrastructure is something like that. The it should be scalable, it should be advanced, it should be smart enough to predict the kind of SOC level, what kind of C that cell is designed for. Because if I'm having a fast charger, right, I cannot spill over that extra power to every bucket of every empty bucket. Some buckets may be half filled, some may be totally empty. Some may not have the capacity of that fast charging because of their sea levels. So that scaling of EV charger should be there, which obviously require intense capital investments, and they also require a large amount of land requirements, right? And this is a major problem in the urban cities. So some stackable kind of things are there, which we are also working up with the Tata Power kind of scenarios and companies, where we incorporate these scaling EV infrastructures. The grid capacity and the reinforcement is there, where the networks are aligned to prevent any kind of overloads in the term of P, in the terms of Q, and in the terms of free F. So needing some reinforcement in the dense cities and some obsolete cities, and very remote kind of cities also, where the voltage and frequency are not well maintained. Obviously, these should be taken care of, the all the operational and the regulatory issues which an EV charging system has to incorporate, depending upon the tariffs, depending upon the demand management, and the national standards for the EV charging protocols. Right. Now, here comes a major opportunity for the budding engineers and the researchers in India. where the digital solutions are accelerating the EV infrastructure. We have a very good case where we can incorporate different kind of technologies for the different innovative business models, right? So just for example, a swappable battery was a good kind of case. Different cell chemistry, sodium battery is kind of different business model. In terms of motor, if I say rare earth motor is a different kind of business model. So technology, some sideline from the main mainstream, identify some different kind of thing and venture that, because nowadays very venture capitalists are also there, funding is also there, and we can explore these kind of opportunities also. Scalable charging business models can be in the form of public-private partnerships. The different kind of government initiatives are there, because different kind of discoms and state utilities with the help of Honda, Sun, and different kind of other vendors, they deploy these charging facilities or swappable battery facilities also, which ultimately both of these what they do, they decrease the turnaround time of charging and the negative feedback of the EV users. Now, next thing comes from the business model is the fleet-based charging hubs, where one Jaggi case was there, but somehow it has been now floated off the record. Jaggi's case was a very good case for these fleet charging hubs, where they had developed these kind of fleet vehicles, and some others are also going to come in this picture. Subscription-based models where battery as a service is there. So some companies are being providing battery as a service there, powertrain also as a service over there, because you do not have to buy or cost the whole cost or the ownership of the whole battery or the powertrain. You can just use as a service. See, powertrain as such, or if you say motor as such, is not that much costly. Battery is that very much costly. So, and the time is also, the useful life is also very less. So the subscription model of BAS, battery as a service, is now growing at a large. Now, obviously, since I told power electronics is coming as the very control feature for each and everyone for the electrification and the EV segments, the DC, starting from the DC-DC regulation to AC-DC conversion, what amount of current needs to be pushed for what control or speed, whether it is regenerative braking, whether it is acceleration, whether it is an uphill kind of motion, all these are being controlled with the help of power electronic different kind of switching algorithms, the voltage and the harmonics management, because these harmonics, obviously, as I understand that most of the people or all of us are from electrical engineering, the harmonics are a major kind of setback for any kind of system, because unnecessarily heating losses and these kind of features are there, which ultimately degrade the life of the system, and the synchronization part is very much unstable. So to take care of all these, the polytonics, different kind of control algorithms are being used by the different researchers, and the products are being there. Polytonics also supports in the terms of EVs and renewable energy, where the performance of the EV is very much increased, and they enable the renewable energy integration at large. So I'll say from the support of EV, many of us who design or work in the field of batteries, powertrains, or EVs, we also all know that circles have a curve. So they have currents have a curve named by circle. So we have current circles, and voltages have different kind of platform shape. It is an oval kind of platform. It is an ellipse, right? So whenever this ellipse coincides or interacts with this circle, V and I that I'm saying in the terms of graphical representation, the useful area for that EV is only that intersection part. So usually while designing, if the power electronics part is not that much good, the design may be very good, the winding may be very good, the C capability of the battery may be very good, but coming to the power electronics, if the power electronics is not bringing the intersection area more, the EV is not able to drive uphill in a longer time, which we say gradient. It can drive only up to 4 degrees or 5 degrees gradient. If someone has to drive a gradient of 15 to 20 degrees, let it be case of Himachal, Northeast, or any Uttarakhand kind of scenarios, This power electronics, if it is not designed, it won't scale up and the EVs will fail. So that is how power electronics plays its role. Now, the advanced applications, smart PV inverters, fast charging systems, and ultimately they all are concluding for the bidirectional power flow because we have solar rooftops. We have intelligent battery energy management systems which interact with the grid. The orchestration is done like that. When the demand is less and the generation is more, they will supply to the grid. So the concept of zero energy buildings are there. So all these are done with the help of power electronics features. Coming up, since the intermittency is there in the generation, intermittency is there in the kind of load patterns, we need ultimately the energy storage systems. Therefore, I told energy systems are very much important. Practically, graphically, I'll show in the next slide how and why they are very much important as compared to India. The first part of the energy storage supporting part is the grid stability function, where in the terms of both peak shaving, peak shifting, and all those frequency regulation features plays their role. Integration and DER orchestration for the backup powers for the emergent kind of loads and evening ramp ups are very much important and they are being taken care of by the best solutions. Best solutions are a good facilitator for the EV charging support also because every time we cannot be driving that huge amount of power from the grids also. The systems need to be modular and ruler. So one case is of Bloom, right? You people can search. It's an Indian founder, went in US. He is stack by stack. He's generating some modular kind of energy storage patterns so that it is fuel cell. Uh, so at the place where the power requirement is there, you can place 6 kilowatt to 6 gigawatt kind of energy storage facilities, and they are all scalable. So the system should be something like that. Even if the case of microgrids or rural electrification, these systems can be used at large. Now, EVs are interacting with the grid and the microgrid. So, bidirectional power flow is a very much common feature where the controller has to take care of, and the battery should be supporting, and the grid also should be supporting that. V2V, V2G, V2X, ultimately, they all are subcomponents where power electronics, EV, AI, and smart grids play their role. Distributed energies and demand response curves, because evening time, if I say, when I say I'll be discharging my EV, so what I'm doing, I am supporting the demand response curve of that city, of that point. Smart charging, the scenario is reducing the grid stress and improving the overall system reliability, apart from the main feature, sustaining its own health. Advanced grid integration, where the DERs are integrated with the feeder level balancing is there. And the either we had studied some ring kind of systems and the other kind of system that the systems are totally going to change. And it is all because of the smart grid facilities and integration patterns. When the microgrid integration is coming in picture, it is, as we can say, local generation is there. It can support, should support local generation. It should support the islanding kind of features. The integration with wind or solar should be there, along with the BESS. Rural electrification should be there because sometime back we were talking with companies like Tata Power and Suzlon. The concern of the government of India is obviously in the previous slide I've shown that, or if you also now deep dive on the government Ministry of Power portal of RES portal of Government of India, you see that electrification or 100% electrified India is, but the fact remains something different. And to curtail, to cater that part, rural electrification becomes a small part, where microgrids, small microgrids are being now set up with the help of government utilities and discoms. Disaster resilience, where different kind of anomalies creep up, the faults, let it be LL, LG, double L, all these kind of systems come in existence, and the system should be much advanced and stable enough to isolate and identification, detect, isolate, and restore all of them independently as on their own, obviously with some kind of human interference above them. Now, monitoring solar, this is where the whole India and rest of the world is walking through, except some major countries like Denmark, which are solely going on the wind part. So rest of the world, I'll say, except Japan also, which is going on a different platform. Rest all of the world is going through solar, as India is also going. But solar is a good thing. Coming slides will show what the bad part of solar is. So, predictive condition monitoring will be used for AI-driven health sets, real-time sensor integration, and operational efficiency gains. So, predictive condition monitoring for solar panels, cells, EV batteries, motors, transformers, everything is to be there, and they have to be integrated with real-time kind of sensors, RTUs, SCADA. Advancements are there, PLCs, PLCCs, and PMUs. They are now coming in picture. Certainly in India, PMU is a far kind of thing. SCADA is still there, but in Europe and other countries, we are also dealing with the PMUs part. So data integration with those is also very much important. And finally, the yes, please. The other part is the predictive maintenance. Finally, whatever it does, it reduces downtime, lowers maintenance cost. Ultimate aim, the borderline of it is sustainable electrification. Because of my electricity burning or my fan running or my some prompt in an LLM, Grok or anywhere, some village or some town, some village should not be in blackout. So that's the whole motto of the predictive condition monitoring in the energy sector and EV as a whole is. Now, why I was talking of solar as a good also now as a bad, because solar has been growing. In the previous slides, I've shown that from 2018, we have been developing solar at a large. But the solar problem is that in the midday, it starts from morning till sunset, sunrise to sunset. But in the daytime, let it be 11 to 3 or let it be 2, the radiance is too much, very good. And India is in a portion where irradiance as compared to the other some of the other countries is very good in concentration. So power generation is very high in the afternoon time, but the load is less. Evening demand increases, but at that time solar curves, solar generation decreases. So there is a flexible grid kind of resources where BESS comes in a picture, and they have to be come up with some kind of hydropower schemes which can balance this supply and demand kind of vulnerabilities. And smart grid is obviously over forecasting this kind of thing and optimizing different kind of algorithms and strategies for maintaining this grid stability. Now this is very much common in India right now. This is the Indian duck curve which I have tried to plot, taken from the data taken from government websites only. In 2018, this was a very normal kind of flat profile for demand on our grid. In afternoon, it was more. In
ये
evening, it
बारह
was
बासठ आ गया ना भैया, क्यों जी? बारह निकल गया पीछे तो ये बात है, ये घोड़ा कॉलोनी है अभी। घोड़ा खोड़ा खोड़ा की घोड़ा घोड़ा घोड़ा
Khuda colony. Please
ओ,
mute कर लें
यहीं से
अपने आप
लेफ्ट
को.
मुड़ोगे, इसी रोड पे है पार्क एवेन्यू, आगे जाके लेफ्ट,
So
इसी रोड पे है ना?
from 2018,
लेफ्ट मुड़ेंगे। ओ, ਤੁਹਾਨੂੰ सब पता है भाई, बहुत बढ़िया भाई, ਤੁਸੀਂ कमाल कर दिया भाई।
from 2018,
So you
the
are
flat
there in the
profile was
hotel,
this
be
one.
comfortable with yourself. I will come in half an hour or maybe 45 minutes. So in between, inquire whether they can have got the facility of packing a cold coffee
संजीव जी म्यूट
along
ही
with
कर दो.
some sandwich, basically grilled sandwich.
ठीक है. Thank you. To 2019, what we are seeing, the profile is somewhat changing. This change will be appreciable in the upcoming slides. In the upcoming graph, we see which is showing that in afternoon, the total net demand on the grid has decreased. Now, with this graph, we are seeing a substantial flattening of the total grid demand in the afternoon time. Now, this comes a very important graph where we are seeing not only flattening in the afternoon from 11 to 1, the profile net demand on the grid is very less. It becomes very much more prominent in 23. In 24, it's still worsened. In 2025, this has worsened. 2026, I have not put the data because it is yet to come. So this is what a duck curve means. You can see the bending down of the grid demand. This is a very bad scenario because in the evening time, there is a very ramp up, very fast ramp up of the power. And this is very harmful for the grid, for the stability. I took the case of only three studies, Tamil Nadu, Karnataka, and Rajasthan, having good irradiance and the good solar panels that we have brought. In Tamil Nadu, 2021, the profile was uh, duck curve shape. Karnataka, slightly less. Rajasthan, it was lesser. Coming back to 2023, Tamil Nadu duck curve was very much big because now you see the ramp up, right? You can see this ramp up. This ramp up is catastrophic for our grid. This ramp up was still there for Karnataka, and the ramp was similar approximately. The rate of ramp was approximately same for all three states. Coming back to the previous year only. So Tamil Nadu, because of some wind farms, right? Because they have this kind of facilities, this ramp was drastically somehow changed. For Karnataka, there is no wind farm, so you can see how this Karnataka is affecting PGCIL and ultimately Rajasthan. So by these graphs, what I mean to show all of you, solar is also a boon, but it is also causing some of the demerit to the government of grid stability. And here comes, in all these, comes the role of BESS. Not only BESS, we have some other features also. Let it be, I'll see if I have put them in other slides. Yeah, that is hydropower. So hydropower can be done in all the other states, but northeast of India is having enormous power, which I had put some time back in some LinkedIn posts also, that while I was studying in 1997, 98 and doing my internships, right, I was doing in NEPCO and PGCIL at that time. The capacity of Arunachal Pradesh only, forget about whole Northeast, the capacity of power generation of only Arunachal Pradesh was near about 1.5 times of the whole demand for whole Asia. It could curtail whole Asia. Present date from 1997, 2026, still the demand of Arunachal Pradesh is 1.2 times, not of whole Asia, of only India, but still, because the demand is increasing, but still it is untapped. Out of that 1.2, right, only we are concentrating near only about 3 to 4%. Why? Because all of us know what is the geographical constraint of India is. There is a chicken neck. And because of that chicken neck, right, which is here, extra high voltage or high voltage transmission lines can be laid for a very definite amount of land area. And the power evacuation is a very kind of big problem for governments, utilities, PGCIL. What support from there can be in the time they can generate all this power, they can convert them in green hydrogen. So this is a concept which I have given. It is a P2G2P. Power from hydro can be converted to green hydrogen gas. This green hydrogen gas can be transmitted to different parts of India based on their need and demand, and either through trains or any kind of other facilities, road, because road and trains are obviously there, right? They can carry huge amount of, either they can connect through pipelines also. So this can be a national kind of saving scenario where we can have net zero kind of emissions with the help of Northeast saving. Last not the least, I'd like to conclude my slides with the help of cyber security, because whatever we do, whatever energy we talk of nowadays, Starting, I said everything is digitalized. Digital means everything is in the form of 0 and 1 and it is uploaded to cloud. Now, when cloud it is uploaded, no one knows who can hack it and who cannot. It is 256-bit encryption, 512, 1024 or whatever. Gen AI has come in picture and people have also started testing this quantum. So the things which were used to break those codes in some days or months, it is now fraction of minutes. So cyber security, we should be taking care of in electricity also because it can attack and breach the grids best. And obviously, we have to incorporate and adhere to all the norms, international and national. And one important part of cybersecurity, I'll just say, being from a group called Tata, we have a sister concern called JLR. Previous year, JLR had a big cybersecurity concern, and whole our group is still to come up from that. So this is the effect of cybersecurity. What it does to one point affects the whole world. Now I'd like to conclude my words where energy sector and EV has been digitalized and AI is coming in each and every part. Digital and smart grids are there. The scalable charging features, swappable fast charging, new chemistries of batteries are coming in picture. Orchestration of DERs with different IEC 5161850 are taking place. Duck curves, hydrogen, P2, G2P are playing their role, and ultimately, not last the least, cybersecurity has also played its role because Government of India has also mandated previous year in second quarter somewhere that cybersecurity should not be the last one. It should start from the first code that I'm going to write in Python or any other language. So that's all. I'd like to thank all of you for having a patience to listen to me and along with my cuffs. Thanks.
Thank you, sir. It was indeed an insightful lecture. Now is the time for a panel discussion.
Okay.
Our eminent experts for this panel discussion are Dr. Rajveer Singh from Jamia Millia Islamia, New Delhi, Dr. Ramesh Singh from Tata Elxsi, and Mr. Devansh Poddar from EV Recharge, Noida. The moderator will be Mr. Abhishek Kumar Singh, JSS University. Over to you, Abhishek, sir.
Okay, good afternoon, everyone. On behalf of Department of Electrical Engineering, JSS University, Noida, I extend a very warm welcome to all the participants and our distinguished guests. Throughout today's summit, we have had excellent talks about covering India's EV policy, landscape, battery technologies, charging infrastructure, smart mobility, and integration. Each session, hello.
I request Chandrasekhar Rao sir to please mute himself.
Okay. So each session has highlighted an important piece of electric mobility ecosystem. However, some important questions are still left. We all know that India is one of the fastest growing automobile market in the world. Also, our government of India has announced ambitious targets for electric mobility. Battery technologies are rapidly growing. Charging infrastructure is expanding across the cities and highways. At the same time, several challenges continues to exist, such as can our power grid support millions of electric vehicles? How can charging infrastructure reach rural India? How battery prices can be brought down to certain level? How can academia prepare engineers for this transformation? And what policies are still required? To discuss on such questions, we have our panelists, Our first panelist is Dr. Rajveer Singh from Jamia Millia Islamia, New Delhi. Dr. Rajveer Singh has extensive academic and research experience in sustainable energy systems, power engineering, and electric mobility technologies. Sir, I heartily welcome you. Our next panelist is Dr. Ramesh Singh from Tata Elxsi, New Delhi. Tata Elxsi is among India's leading technology companies working in automotive electronics, embedded system, and intelligent mobility solutions. Dr. Singh brings valuable industry insight into evolving EV ecosystem. Welcome, sir. Our third panelist is Mr. Devans Podar, co-founder of EV Recharge Noida. Mr. Podar is actively involved in deployment of EV charging infrastructure and has first-hand experience in implementing charging solutions across India. Welcome, sir.
Thank you.
I would like to start with Dr. Rajveer Singh. Sir, can you hear me? Rajveer, sir.
Okay, I am listening. Yeah.
Sir, from an academic and research perspective, what do you think is the single biggest roadblock to mass EV adoption in India? Is it high upfront vehicle cost? Is it the range anxiety or lack of charging infrastructure or consumer awareness?
Ah, in my point of view, all the 3 points are valid, and because the India is trying to last 5 years to manufacturing the EV batteries, but and trying to, but still now we have no manufacturer in India. Okay, and Reliance set up a some lab, and I think 5 year back, and now there is no development still. Okay, and we are only fully dependable on the China. Okay,
Right.
because okay, yeah, and then the yes, and the next point is, what was the next point?
So this was the first question. I will come back to you next.
Okay.
My next question will be to Mr. Devans Podar. Mr. Podar, can you explain what are the biggest challenges in expanding EV infrastructure into the tier 2 and tier 3 cities and rural India?
Thank you so much. Thank you for inviting me and being a pleasure here. So, talking about expansion of charging infrastructure beyond the metro cities, I believe this is something that will greatly depend upon the demand, the I would say the segregation or more like how the logistic players or how the industries will set up theirs will go beyond the metro city. Like they are trying to set up around the tier two city. There are a lot of projects that are getting developed either through logistic corridors or some other ways. So it will require a mix of both like fixed chargers, mobile chargers, distributed charging stations. But one thing is for sure, currently what we are doing is we are installing the chargers as per the for the destination aspect. Let's say that this particular area is much known, so we're installing couple of more chargers. But it should, while it leads to a tier 2 cities, it should be in a fashion where there is more demand. So a demand led approach, not a location led approach, will actually create this entire charger deployment in a more better way. We sometimes we find that we have an EV and we go through some route, and we always find that in those particular route where there are more of the vehicles, chargers are really not there. But in those areas where there are less of the vehicles, we can find enough chargers. So a demand-led approach should be taken by the government or even the private players, and interoperability and standardization of these particular charging networks, the integration across among all these sort of OEMs, like even it be Tata chargers, even it be Geo charger or other private companies or the government chargers. There has to be digital integration between them. We could find that most of the chargers while you reach those points are not working. So there must be in the we have already have enough technology today that if there is any problem in terms of the technology and the system is really not working, that particular digital data can already get updated on your map, on your mobile, on your systems. So I believe there is a lot of scope for anybody to work out around the digital integrations of these chargers. So while any of these particular problems will be on the verge of getting solved, there will be a lot of private capital that will flow, and there are a lot of more startups that will come with more better ideas to come into this field. Uh, we can demonstrate to different utilization capacities to different innovations. So definitely tier 2 and tier 3 are the emerging markets. And while metro is giving us a better test bed in terms of more of a language, more of a test, it is giving a test bed, but the emerging markets will be around the tier 2 and tier 3 cities. Thank you.
Okay, thank you, sir. Thank you for the wonderful answer. My next question is to Dr. Ramesh Singh. Sir, as Rajveer sir mentioned that we are dependent upon China and other countries for the technologies. What do you think are the biggest technical and commercial challenges in developing scalable EV charging infrastructure, and how can industry overcome them?
Thanks, Abhishek. See, sustainability and self-dependence obviously comes from the first cell that we manufacture. So obviously, if we talk of present chemistries, which are lithium ion kind of thing, India is not in a good kind of position where we can have a sustainable kind of solutions for self-dependent basically solutions for these kind of chemistries. Upcoming chemistries are also coming up in picture, which are based on sodium and all. So that can be a good kind of venture to work upon. And apart from these batteries, what I would also like to mention is the use of hydrogen cells. Like, so hydrogen, as I said, green hydrogen can be produced in the with the help of states which are having enormous hydropower. Because green hydrogen is only the problem is it usually draws power from the grid or it needs power. So the power, if it is drawn from coal only, doesn't become green, it becomes brown or whatever. So what I in my slides also what I shared P2G2P, if the power can be generated using hydro, then converted in hydrogen. These hydrogen tanks can be filled depending upon different size and compression ratios to different parts of the India. Then certainly this is a very strategical kind of thing which I'm telling. This is not present which I'm talking of. I'm talking of next 10 years down the line, what should or can be done from Indian perspective, because India is rich in solar, India is rich in hydro, India is lacking in sodium ion, India is lacking in lithium ion. So why don't we use and produce that which is made in our home? If I say, Vishek, I'll put it in very small words, right? Very analogy point. I used to be in Delhi, right? At that time, now globalization is there, marketing is there, right? But if someone sitting somewhere in Delhi, in Noida, 25 years back, would he be eating a idli or dosa? No,
Mhm.
he will be adding a paratha and aloo paratha and dahi because it is the flavor of that India and that materials are being available there. What is the scenario right now in Bangalore? I am eating aloo paratha with dahi, where a place of idli and sambar is there, right? Why? Because supply chains are not constructed within India. But when it becomes to the boundary of nations, geopolitics come in picture. Geopolitics I cannot control within my prime minister or my state ministers. So we should take care of that and we should take some obligate and strategic decisions which can power our sustainable strategic future. So my bet will be hydrogen, P2G2P, and other chemistries apart from lithium ion. And in kind of charging point of view, you say, and fast charger takes 7 minutes. Hydrogen charger also takes 5 to 7 minutes. And we have done in a previous project, we have run 800 kilometers on 7 minute charging. So capabilities are there, just some tweaking of the strategy needs to be there. I hope I answered to your points, Abhishek.
Yes, sir, very well, sir. And our government is also pushing very hard for the hydrogen. We
Yes,
have been developed and buses are going on through
that
those hydrogen.
should be na. जो है हमारे पास वही खाए ना.
Yes, sir. Yes, sir.
Thank
Okay.
you.
My next question is to Dr. Rajveer Singh. Sir, as Ramesh sir mentioned that we should move on to sodium ion batteries rather than lithium ion. Do you believe that sodium ion batteries have the potential to replace lithium ion batteries for Indian two-wheelers by 2030?
Yeah. Because due to the disadvantage for both, okay, advantage for both. Lithium ion batteries are costly, but
Yeah.
less in weight, and as compared to sodium ion batteries are as compared to lithium ion is less costly, but weight per watt hour is less. Okay, due to this, the we preferred in all our mobiles, and we are trying to, okay, in all EVs. So due to this, but now still we are on dependent on the other countries, because here is no manufacturer available, no manufacturing is there.
Yes, sir.
So our dependency on to the other countries. So that's the
Okay, sir.
scenario in current India.
Okay, sir. Okay, sir. Okay.
राजवीर सर, मैं अभिषेक एक मतलब दोनों
Yes,
लोगों से
please,
एक्सक्यूज
please.
मैं कुछ बात आई वुड लाइक टू पुट अप सम पॉइंट्स ओवर हियर
Yes.
that when I was in my childhood, right, there was no Lays or these kind of companies. My mother used to peel potato, fry in oil, and we used to eat that. Now the era is there, we are having Lays and different kind of companies. But is the solution sustainable? Is the solution healthy? Certainly
Absolutely.
no. Sustainable and healthy point is that same potato, but obviously it takes time. It won't give exactly the same kind of flavor, but somehow, somewhere you have to adapt to your situation and circumstances for not only your healthy life, for the generations to come. So the question is not me and what Abhishek will be healthy with that AQI or not, whether his grandchildren and my grandchildren will be living and having a good AQI. तो कहीं ना कहीं तो शुरुआत करके कुछ नुकसान सहना पड़ेगा.
Yes, sir. Correct, sir. Correct, sir.
And what I'm saying is Devansh is from IIT Delhi, right?
Yes, sir. I'm not studied from IT Delhi, but
हाँ,
yes,
वहाँ
I was.
इंक्यूबेशन सेंटर में थे शायद.
Yes, sir.
तो यही इंक्यूबेशन सेंटर जो होते हैं, जैसे आईआईटी दिल्ली का है, आईएससी का है, आईआईटी मद्रास का है, सारी जगह जो इंक्यूबेशन सेंटर्स हैं, वो ऐसे ही एंटरप्रेन्योर्स बना रहे हैं. क्यों बना रहे हैं? ये कल बनाएंगे हमारा.
Yes, sir. Correct, sir. And I would also like to add that Mr. Devans is our alumni.
अरे वाह,
He has,
बढ़िया बढ़िया. वेरी
Thank you,
नाइस.
sir.
प्लेजर टू
Devans,
कनेक्ट विथ यू.
yeah.
Same here, sir.
तुमसे कनेक्ट करूंगा देवांश में नंबर लेके
बिल्कुल sir.
अभिषेक से.
Pleasure, sir.
My next question is to Mr. Devans. Devans, since you are in the charging infrastructure business, what do you think? What is the major challenges? What are the major challenges that still needs to be addressed for large scale fleet electrification?
So, obviously, one of the points of very important points while I say charging, while sir also told about the sustainability of any of the technologies that come through, or about the hydrogen part, or even one of our panelists told about how the costly the lithium batteries are and how, are they really degradable or not. So this particular industry is still into more of an innovation approach. We have seen the ICE industry being there for about close to 60 years. And good part is like from the first 30 years, a lot of research that was put into, there were a lot of accidents that were happening, there were a lot of approach that was taken in the first 35, 40 years. Now what this generation is really finding is the refined product or refined outcome of the ICE age industries that was built by our some really great innovators, right? Hats off to them that we are having a so smooth mobility into today. Similar case is with the I would say EV as infra. So EVs are still at its very young stage. We are still finding that our scientists, our innovators are putting all the due efforts. It has been always the fashion that sometimes the technology, sometimes the innovation, sometimes the culture comes from either west, comes from the north, or comes from either parts. It's about the global innovation that takes place at the center. But we should always think that while any of these ICE or the EV age comes to, the fuel that really I would say uh, moves that particular innovation. So as in for an EV, electricity is the fuel as a utility or a commodity that is going to really expand this particular nature of innovation or of this nature of I would say mobility in future. So fleet electrification is not just a sustainable point. Like if I speak, if a government speaks today that we will electrify all the areas, we will put so many stations, right? We need to understand the fundamental operational reliability and the financial reliability also of these. So it's always a challenge when we talk about the commercial fleet electrification and a passenger electric fleet. The fleet or the vehicles that we use. So for the fleet operators, so if I just help you with the data, so out of every 100 vehicles, 20 vehicles are EV today. And out of the 100 EV vehicles, 20 are the commercial vehicles that are into logistics or into cabs or enterprise, right? And you would be surprised to know that the 80% of the vehicle that is being used by people like us as more of a for everyday use, we use 20% of the total energy used in the entire day for EV. But those 20% vehicles use 80% of the energy because our average run per day is close to 50 to 60 kilometer. But for one vehicle of enterprise or logistics, they have an average run about 120 to 180 kilometers. So we really need to understand that the fleet electrification for the commercial aspect has to be taken into consideration by the government today, and it's a very very good market that even people today can devise solution for this, can come with different products, different innovations, IoT devices around this. So what fleet operators? So today, if I'm going for if I'm having a vehicle and I'm going outside, and I just need to charge my vehicle because I'm going to separate destination. I could be 5 minutes late. It won't hamper so much. But for any fleet operator, vehicle uptime, the utilization of the asset, and the total cost of the ownership, that's called the CTO, that all takes into, I would say, more of this whole thing takes into picture account how an EV industry is really growing, right? So charging should integrate into fleet operators rather than forcing fleet to adapt to charging infrastructure. So these are the very very different phenomena that I'm talking about. Today what we say that the warehouses are some distant location, and now they have to come to the charging location, but the charging locations has to be near to the fleet operators. So these are the things that is really not moving in a direction that is really comforting for the logistic operators today. Hence industry should really move from selling charging sessions to really adapting to the mobility uptime. While if you consider today, uh, I'll just give you again more of a data points on the very data aspect. So, ICE-based vehicle or a diesel vehicle operates at 6 kilometer per liter, 6 to 7 kilometer on an average smaller Bolero pickup something. While EV vehicles operate at 1 rupee to 2 rupee per kilometer, and a petrol vehicle operates again at about somewhere close to uh, same 5 7 around same. While CNG operates around 4 kilometer, much better average I would say, like somewhere 9 to 10 kilometer per kg of CNG. The EVs are the final, I would say, are the ultimate solution to any enterprise mobility. You would be finding in near future that the EV cabs will be more cheaper than the CNG or the petrol cabs that you will find. The logistics cost will decrease. The Because of, you will see Zomato people are only working through EV scooters. The reason being the per kilometer run cost has decreased from 7 rupees a kilometer to a rupee a kilometer. So that's the change that we are really witnessing in this era. So yes, that's really about the fleet electrification from my side.
Yeah, you rightly mentioned, and I would like to relate this with the CNG example that you gave. Earlier, CNG pumps were not readily available in tier 2 and tier 3 cities. So we had very less model related to CNG. Nowadays, CNG pumps are available in tier 2 and tier 3 cities, and we have more number of CNG. Means almost every vehicle brand is having a CNG model for all their vehicles. Yeah. So next question is to Dr. Rajveer Singh. Sir,
Yeah, please go ahead.
so all the panelists are emphasizing that the government should focus more on subsidizing private passenger EVs, and should greatly emphasize to be placed on electrifying public transportation systems such as buses and shared mobility. What's your opinion on this?
Uh, it is very good because the if we are if the Indian people will commute through the EV transportation system, so definitely because due to the some the sir is also Podar sir is also mentioned and the AQI will decrease. Okay, our air quality will improve, and this is depend. There are lots of advantages. So because we are fully dependent on the fuel, the oil from the Gulf countries. So we will import less fuel and we will save the lots of money. So I am fully agree with the government policies.
Okay, sir. And I have a connected question since we belong to academia. How should university redesign their curriculum to prepare students for careers in electrical mobility, battery technologies, charging infrastructure, and smart energy systems?
No, still we are in developing phase. So there are so many courses are running in our in my universities. We are also running one or two courses, and the other universities is also running so many courses. But still we are in developing phase. So and point of infrastructure of chargings and the we are lacking some behind of the. Okay, so now we are in development. After 5 or after 10 years we will see what we. Okay.
Okay, sir. Okay, sir. Ramesh, sir, I have a connecting question related to this to you. What advice would you like to give to young engineers who aspire to build careers in Indian electric mobility ecosystem?
Uh, this is a topic that I have been discussing with various platforms in industry and academia both, right? Because I have been interacting with ISC, IIT Chennai, and Guwahati, and everywhere, and all big OEMs. See, one major problem, Abhishek, I'll tell you. We, as an industry, where I was also sometime back on the other side of the table, we teach some topics on a 3-2-1 or 3-0-2 basis. We have some workshop practicals and new reforms of education are also there. The thing which is missing right now, what the industry needs, there has been obviously a gap between academia and industry, which everyone knows. And in India, it's a very big gap.
Huge gap.
One thing that needs to be a filler for this one is academia industry bridge, where one point can be professors, academicians, researchers like you and others should be partnering with industries to get some live projects. Not necessarily be, let it be if you are interacting with Tata Motors on a live Tata Motors project,
Yes.
but talk to them, identify 5-10 topics which they have done earlier, 2-3 years back. Those topics, break down in a small one, give it to BTech students, summarize 2-3 more and make it for MTech, and make a amalgamation of some bigger areas, give it for PhD. So one thing is industry oriented problems should be given in the project work, right? The second thing is obviously our education system, the syllabus transforms, BOGs are there, they are transforming. New VCs come, they have some different setup. New HRD ministry comes, they have a different setup. One thing is always missing is everyone is going to change the history and the present. No one is going to change for the future. आज तक मुझे कोई ऐसा मिनिस्टर, सांसद, अधिवक्ता या कोई आईएएस नहीं मिला जो फ्यूचर के लिए काम कर रहा है। वो या हिस्ट्री को सुधार रहा होता है या प्रेजेंट सुधार रहा होता है। मैंने अगर यहाँ 5-6 चीजें बोली, डिजिटल ट्विन, क्या डिजिटल ट्विन पढ़ाया जाता है?
Some research work is going on, but not in academics.
वही एकेडमिक्स में अब मैं डिजिटल ट्विन आई हैव टॉक, इट स्टार्टेड इन नासा 1960s समवेयर, Now you talk of the industry. I am dealing with all the industries. Every platform digital twin is there.
Yes.
Battery, motor, wire harness, BMS, everywhere, right? Why don't you give a minor specialization in that? Okay, let it be one part. Next thing is, what is coming to be the future? Is quantum coming as a future? Certainly it is coming to be. It's a far-sightedness.
Definitely it is going to be.
It is coming to be. So can these courses somehow come to budding engineers ki, boss, ye bhi karo? Because they will get an inspiration. Faculty will also learn something, right? So these are new things which I'm telling. Some old things which you can, for old things, collaborate with the industries, talk with them, get 5, 6 offline real-time case studies, work on them. For newer topics, give some topics or let it be. If not more, you cannot change the syllabus. You might be having some seminar or presentation lectures also, right? Give students these topics. Come up with these. तो ब्रश अप होगा आदमी सिर्फ पीछे और नीचे के बदले आगे देखना शुरू करेगा दैट इज मोर इम्पोर्टेंट
Yes.
सो माय टेक विल बी number one collaborate with industries need not necessarily be always in the terms of financial part or some ministry of highways or roadways project need not necessarily be बात करो आपने कोई एक दो मेंबर रखो इंडस्ट्री के उनसे you should keep on checking ki what's new going on and incorporate those new to slightly tweak your topics, not at large, because you are governed by a big BOG, which is governed by a even more bigger organization or setup, right? So change slowly and gradually. Because the gap is big, change slowly can only fill up because if something big is filled up in a gap, right? बहुत कॉमन सा प्रैक्टिकल एग्जांपल है ग्लास है खाली है उसमें बड़े बड़े पत्थर भर दोगे ना तब भी गैप रहेगा
Yes.
ग्यास को भरने के लिए छोटी छोटी चीजें बालू भरा जाता है तो स्टार्ट विथ
Yes.
स्मॉल
Yes.
थिंग्स विल बिल्ड अप टू बिग थिंग्स दैट्स माय टेक आई होप आई
Okay.
आंसर्ड यू
Yes, sir. So what it is that can I say that today's industry values practical projects more than academics?
industries value practical projects more and they need analytical reasoning with every engineer मुझे वो ओम्स लॉ वाला बंदा नहीं चाहिए मुझे ओम्स लॉ वाला बंदा टेम्परेचर में अप्लाई करने वाला चाहिए
Okay, correct. Devansh, my next question is to you. Devansh.
Sure, sir. I'm here.
So, what do you think? How important is the integration of renewable energy with EV charging infrastructure?
Sir, I believe being
And my
into
follow-up question is that also
Mm.
about battery storage.
Okay, so I believe sitting into Delhi NCR, we have already started witnessing about something called as power surge. And one of the very important highlights of power surge is increase into charging stations. And while the government is really not putting out or the PR is not coming around this because this will really hamper the growth of the ecosystem. But you have to consider like even installing a fast charger, the fast chargers are now coming at 60 kilowatt, 120 kilowatt, and now even we are talking about getting into 240 kilowatts. So 60 kilowatt charging system is somewhere for a more of analogical or layman language is close to about 30 to 10 ACs roughly. So we are saying that like if an apartment gets such number of ACs, 25, 30 more ACs installed into any apartment, the load is really not able to get balanced. I mean, talking about putting around such chargers in a number of 3 to 4 around every societies. And all of these chargers that you see across, either you have been moving around or you're going on some Manali, Dehradun, or any place, you might have seen these chargers are the wires are connected to grid. So whenever the electricity is not there in that particular area, even the chargers are not working. So that's one part. Second part, while you're connecting to grid, we are saying that we are using EV as a green, but we are really not using green. That's a thermal energy that you are converting to electricity, and now you are storing into battery, and now you're running your vehicle. So it's a very important consideration now that we have to have a usage of a green energy. Electrification alone will not be really. We have to see the supply, the source from which this electricity is coming. We have to have an integration of renewable energy. We have to have an integration of the various microgrids. So already the government, the discoms, either BSES or UPPCL or the Haryana, the most of the discoms in the like Maharashtra discoms are working around creating a microgrid network. A microgrid means if a locality has an excess power of solar in every home, so all this excess power will be either going to the battery storage that sir you were speaking about. So government is parallelly talking about having a best battery energy storage systems at different localities to store this excess energy in those particular areas whenever in required, whenever the power surge happens. So this particular excess energy can be used to power that particular area without any uh, without cutting out the electricity in that particular region. So yes, renewable energy, the green charging can reduce the operating cost over time while supporting the national renewable targets, and also the decentralized renewable energy and microgrid charging system that I talked about can complement the grid infrastructure. I'm not saying to remove the thermal energy, but they can complement it, and particularly for the enterprise EVs or particularly for the commercial EVs or the or the fast charging stations that are there on the highways. That's my take upon the renewable energy.
Okay, thank you. Thank you. And I would also like your opinion. What advice you want to give to current students? Your advice to students if they
I
want
see.
to make a career in
So, matlab my first, from the very first statement, I've been telling that there are a lot of opportunities. This industry is still into very nascent stage, and at every channel of the ecosystem. So now the EV as a domain is getting more clear in terms of words. You can really define what are the streams, what are the opportunities. Pick any of those opportunities that excites you. It could be either BMS that sir was talking about. It could be either of the renewable industries. It could be either of the battery systems, battery assembly. So it's still, to your understanding, one of our panelists also told that we are largely dependent on China. It's very right. We are dependent on Chinese cells, that are dependent on the Japanese cells today itself. So if I believe if even if your research is enabled is able to commercialize any of the small aspects also of any of the manufacturing, it's a bigger win for the industry. So the ecosystem is big, the opportunity is big enough. Even you start with a very small journey, you have even have a larger pie in the coming time. So I believe you should know if it might the only negative or cons of this particular thing that everybody tries to have a see the other side of it is that it will take a little time. But the success in this particular industry is definitely there. It's just how you really grow yourself with the industry, achieving new milestones. Thank you.
Thank you, sir. Thank you. Now we still have some minutes left. I would like to take questions from the audience. Anybody wants to ask to our panelists? Anyone? If you want to ask any question, you can ask here, or you can put your question in our WhatsApp group. I can ask on your behalf.
I will also just put down my LinkedIn in case anybody want to
Yeah,
reach
yes,
out
please,
for
please.
any internships or something. Happy to support or help.
I think we have discussed in detail. That's why your question is coming up. Or maybe everybody's tired
It's
from.
completely fine.
Yeah. Okay, so but before we conclude, I request each panelist to complete this sentence. The India's electric mobility ecosystem will truly succeed when? Starting with Devansh.
India's. Can you please come up again, sir? Can you come up again, sir?
India's electric mobility ecosystem will truly succeed when dash dash dash.
When like more innovations will come from the country.
Okay, correct. Ramesh sir,
Atmanirbhar
your
Bharat,
perspective?
I would say.
Truly, Atmanirbhar Bharat only, and mobility depends upon grid. So when it is green mobility with green electricity.
Yes.
Okay.
Rajveer sir,
Yeah. Atmanirbhar Bharat. In next 5 to 10 years, within we will see.
so our panelists agreed on this that we should be Atmanirbhar. So thank you very much to all our esteemed speakers for sharing your valuable insights and experience. Now I hand over the stage to Dr. Abhilasha ma'am.
Thank you, Abhishek.
Yes.
Distinguished speakers.
You're not audible.
You have to unmute yourself, ma'am.
Respected dignitaries, distinguished speakers, panelists, faculty members, participants, ladies and gentlemen. With this, we come to the conclusion of all technical sessions, expert talks, case study session, and insightful panel discussion of today's one-day online summit on electrifying India, innovation, infrastructure, and intelligent mobility for a sustainable future. Throughout the day, we have been privileged to listen to eminent experts from the academia and industry who have shared their valuable knowledge and experiences on electric mobility, charging, battery technologies, smart mobility, and sustainable transportation. As we move towards the valedictory session, it gives me immense pleasure to invite our respected convener, Dr. Sanjeev Kumar Sharma, Head, Department of Electrical Engineering, JSS University, Noida, to present the summary of key learnings and share important takeaways from today's summit. Over to you, sir.
Thank you, Abhilasha madam, for handling the various kinds of speakers since very early morning. So now it is time to summarize. There is a lot to learn. There is a lot to forget. So let us start in official manner. Respected Honorable Vice Chancellor, Dr. H.R. Mahadev Swami sir, in absentia. Chief Guest, Dr. B. Manoj Kumar, Principal JSS ATN Noida, in absentia. Registrar JSS University, Dr. Mamta TG, in absentia. Chief Administrative Officer, Commodore B.K. Gupta, in absentia. Esteemed Chairperson, Professor Jagdish R.S., distinguished speakers, panelists, faculty members, participants, ladies and gentlemen. Good afternoon to everyone. As we have come to the concluding session of this one-day online summit on electrifying India, innovation, infrastructure, and intelligent mobility for a sustainable future. It gives me immense pleasure to present a brief summary of key learning and deliberations of the today's event. One of the most important messages that emerged from today's summit is that electric mobility is no longer an option, but necessity for a sustainable development. India is steadily moving towards reducing its dependence on fossil fuel, improving energy security, and promoting cleaner mode of transportation. The Honorable Prime Minister of India, Shri Narendra Modi, has consistently emphasized sustainable development, energy independence, and green mobility. This vision of promoting clean energy and accelerating adoption of electric vehicle is guiding the nation towards a greener and more sustainable future. The transition towards electric mobility will not only reduce environmental pollution, but also strengthening India's energy security, promote technological innovation, generate employment opportunities, and contribute significantly to the nation's economic growth. The deliberations during today's session clearly highlighted the future of mobility lies in the integration of electric vehicles, charging infrastructure, battery technologies, renewable energy sources, and smart grids, artificial intelligence, and digital technologies. The first session provided valuable insight into India's EV policy, landscape, and future roadmap. The subsequent technical session enriched our understanding of the battery technologies, charging systems, power electronics, and grid integration aspects of the electric mobility. The discussions also emphasized the importance of developing robust charging infrastructure, cybersecurity, smart mobility ecosystem, and technological innovations to accelerate electric vehicles adoption in India. The case study session provided the practical industrial perspectives and demonstrated how organizations are subsequently implementing innovative solutions in the electric mobility sector. The panel discussion further highlighted the opportunities and challenges associated with the electric mobility and stressed the importance of stronger collaboration among academia, industry, policymakers, and research organizations. I firmly believe that the ideas, experiences, and knowledge shared during the summit will inspire our students, researchers, and faculty members and industry professionals to actively contribute towards the journey towards India's journey towards sustainable transportation and clean energy. As I have also mentioned during the introductory lecture in the morning, that it is the absolute control or वर्चस्व, निर्विवादित संपूर्ण वर्चस्व over the energy sector. What it is happening today in the planet, just anyhow to control the energy sector. Energy doesn't mean the fossil fuel. It doesn't mean the nuclear fuel or any kind of fuel you name. It is actually amalgamation of all the energy resources available, whether they are the petroleum product, they are the nuclear fission material, or solar power. The country who rule all these the components of energy will rule the world. This all mess created over the planet is just to gain the varchasva, sampurn varchasva over the energy sector. That's all. And now I conclude and would like to place on record my sincere appreciation for the dedicated efforts of the Dr. Udit Mittal, coordinator of the event, and valuable support of Dr. Abhilasha Pawar for anchoring this entire summit since morning, Mr. Abhishek Kumar Singh, all faculty members, and the entire organizing team for their wholehearted cooperation continuously for last 1 month. So with these words, I once again thank to all for your valuable participation and support. And in the last, I would also like to invite your suggestions. All of you have my email ID, my WhatsApp number also. If you feel by this way or just incorporating, including these small points can make this session more effective. So definitely we will incorporate these suggestions in our next summits. Thank you. Thank you very much.
Thank you, sir.
Abhilasha.
Thank you so much, sir.
Okay, thank you, sir.
Thank
Now I
you.
invite Dr. Udit Mittal for the vote of thanks. Udit sir, over to Udit sir.
Thank you so much, ma'am. Good afternoon to one and all. I am Dr. Udit Mittal, coordinator of this summit, and Assistant Professor in the Department of Electrical Engineering, JSS University, Noida. It is my proud privilege and honor to propose the vote of thanks at the conclusion of this one-day online summit on electrifying India, innovation, infrastructure, and intelligent mobility for a sustainable future. First and foremost, I express my sincere and heartfelt gratitude to our Honorable Vice Chancellor, Dr. H.R. Mahadev Swami Sir, JSS University, Noida, for his visionary idea of organizing this summit. His foresight, encouragement, and commitment towards promoting innovation, industry-academia collaboration, and emerging technologies have been the true inspiration behind this initiative. We are deeply grateful for his guidance and unwavering support in making this summit a reality. I extend my heartfelt gratitude to our respected Chief Guest, Dr. B. Manoj Kumar Sir, Professor and Dean Academics, JSS University, Noida, for graciously joining us today and sharing his valuable thoughts and inspiring address. His presence has added great value and dignity to this summit. I would also like to express my sincere thanks to our respected Registrar Madam, CAO Sir and AO Sir for their constant encouragement, support, and cooperation in organizing this event. My heartfelt gratitude goes to our summit chairperson, Dr. Jagdish R.S. Sir, for his guidance, motivation, and continuous encouragement throughout the planning and successful conduct of this summit. I express my sincere appreciation to our convener, Dr. Sanjeev Kumar Sharma Sir, Head of the Department of Electrical Engineering, whose leadership, vision, and continuous support have been instrumental in the successful organization of this event. Sir, this summit would not have been possible without your relentless efforts. I extend my deepest gratitude to all our distinguished speakers and panelists for their insightful presentations and thought-provoking discussions. Their deliberations covered a wide spectrum from ground-level challenges in charging infrastructure and the economics of battery storage to the transformative role of AI and smart grids in shaping India's e-mobility future. What stood out was their honest assessment of both the opportunities and the hurdles ahead, which gave us all much to reflect upon. Their expertise and candid insights have made this summit truly enriching for every participant. I would also like to place on record my sincere appreciation to my colleagues, Dr. Avilasha Pawar, Madam, Mr. Abhishek Kumar Singh, and Mr. Arun Rawat Sir for their wholehearted support, cooperation, and dedication throughout the planning and execution of the summit. I also extend my gratitude to all the faculty members and staff of the Department of Electrical Engineering, JSS University, Noida, for their valuable support and cooperation. Finally, I would like to thank all the participants, students, research scholars, academicians, industry professionals, and guests who joined us today and actively participated in the various sessions. Your enthusiastic participation and interaction have made this summit truly meaningful and successful. I sincerely hope that the deliberations, discussions, and ideas shared during this summit will contribute significantly toward advancing electric mobility and sustainable transportation in our country. Once again, I thank each one of you for your valuable presence, support, and contribution. Thank you so much. Jai Hind.
Thank you, sir. In the end, I would like to request all the participants and eminent members to please switch on the video for a group photograph. I request all the participants in this Zoom meeting to kindly switch on their videos for a group photograph. Okay, the feedback link is shared in the chat box. The participants are requested to kindly provide the feedback. Thank you so much for joining this event. Thank you. Have a good day.
Thank you. Thank you. Bye.